Grade fives, and welcome to the first episode of Math Distance Learning. I'm your host, Mr. Hurley, as always, except now I'm on the internet. And today I'm getting really hungry, and so I thought I would have a banana, but I don't really want the whole banana. I think I just want half of the banana. So I'm going to cut the banana in half. So I've got my knife, and I've got a chopping board, and let's have half a banana. So of course we know that when you cut something in half, you're cutting into two pieces. So if I just go like that, I have half a banana, right? No? Okay, I can see some people in internet land shaking their head and telling me that I have not cut the banana in half, but I thought I did because I cut it into two pieces, right? What did I miss? What did I forget? Why is this not a banana cut in half? Well, maybe it has to do with the fact that when you cut something in half, you're expected to cut it into two equal pieces, and these pieces are not equal. So that's what we're going to look at today, a little review from grade 4, the idea that fractions has to do with equal pieces. So let's jump in. So the idea we're looking at right now is using equal parts to make fractions. First activity for you to think about is pretty easy. I'm just asking you to think which of these actually have half of the shape shaded. I made 4 shapes. I'm going to give you a few seconds to figure that out. Which ones are shaded in half? Okay, let's see if you got the answer right. So moving from left to right, the first one, ding, is shaded perfectly in half. The colored in part is the same size and equal size as the non-colored in part. Second one, not shaded in half. The colored part is larger than the not colored part, and so it is not two equal pieces. Third one, not shaded in half. The shaded part is more than half of the triangle. Ding! Yes, the fourth one is shaded perfectly in half. The green shaded part is the same size as the white not shaded part. So I'm sure everybody got that right. Well done. Give yourselves a pat on the back. Let's look at something slightly harder. Question: which one of these pictures shows 1/4? Well, they're both broken into 4 pieces, so you'd think they both would. Well, if you said the picture on the left, the circle on the left, shows 1/4, then you would be right. You'd be correct. The circle on the right is not broken up into 4 equal pieces, and so it does not show 1/4. Okay, moving on to something a little bit more difficult. What fraction is colored in? Well, we can see that each of the pieces in this rectangle are equal, right? Each of them is the same size as the other. So we can count up the parts of the rectangle and add them up, and that should be our denominator. So let's start making our fraction. If we start by drawing our line, whoop, and remember the denominator is the number on the bottom, and it tells us how many pieces in total the shape is broken up into. In this case, well, I could count them with my hands. I could just poke the screen until I counted all the squares one by one, but I know how arrays work, and so I could use my knowledge of arrays instead. So let's count the horizontal side. 3, 6, 9. There are 9 squares on the horizontal side. Now let's count the vertical side. 2, 4, 6. Okay, so there are 6 squares on the vertical side. So we just multiply 6 times 9, and I know that's 54. So great, I know there are 54 squares altogether. How many are colored in? Okay. Well, let's count them. 3, 6, 9, 10. So the smile on the nose is 10. And then the eyes, 4, 8. Okay, so 10 plus 8 is 18. So my beautiful smile over here is 18 squares. So the final fraction would be 18/54. So if you got that right, then congratulations. Let's move on. You can actually make fractions not just of shapes, but of lines too, of vertical or horizontal measurements. And that can be really useful if you want to, measure something and then fold it in half or in quarters or in thirds or something like that. Anyways, so here's a line. Part of it's a single line, part of it's a double line. And the question is, what fraction is the double line? Well, you could use a ruler to figure that out, but what if you didn't have a ruler? How could you figure this out without using a ruler? Because I know some of you didn't take your rulers home, or maybe you don't have a ruler at home. Well, one thing that you could do is use a piece of paper and a pencil. And how would you do that? Well, you take your piece of paper and you'd line it up against the line, and you just want to measure that first segment there. That first segment. So you take a pencil and you draw a line. Remember, on one edge of the paper it goes to the beginning of the line, and now we're drawing another line with our pencil to mark the end of the line. Here we go. Okay, and we don't need the pencil anymore. Bye, pencil. Okay, now what we can do is, now that we have that segment, we can count how many of those segments make up the entire line. Okay, well, got the first segment right there. Let's keep going. And that's 2, 3, 4, 5. Okay, so great. We can take the paper away now. We know that that first segment there you can take that segment and divide the rest of the line into 5 equal pieces. So let's make our fraction. I just said 5 equal pieces, so we know the denominator is going to be 5. Hooray! Now the numerator is going to be how many of those pieces are we looking at? And so the question is, what fraction is a double line? And so there's only one segment that's a double line there, and so we would say 1 out of 5, 1/5. Okay, great. So, your turn. I want you to be careful because you don't want to jab a sharp pencil into the screen of whatever device you're using, but I think if you're gentle enough, go find a piece of paper and a pencil and just gently use the same method that I just showed you to measure what fraction of each of these lines is a double line. And you should be pausing the video now so that you can do that. And after you've finished figuring out each of the lines, unpause and I'll show you the answers. Okay, so I'm assuming that you have paused and unpaused. Let's take a look at the answers now. The first one, so I hope you used your piece of paper to measure the double line. And if you move that piece of paper along the entire line, you would see that it is broken up into 3 segments of that length, and so that double line is 1/3. The next one is smaller, and so you can break the line into more of those segments, and if you measure properly, I think you'll find that the double line makes up 1/4 or 1/4 of the entire line. Now the last one is interesting, right? You could use the segment itself to measure the whole line, or you could go all the way to the beginning. Sorry, you could use the double line segment that's in the middle of the line and then measure the entire length of the line, or you could go all the way to the beginning and use that smaller segment that is a single line to measure the entire line. Either way, you'd figure out the same answer. You would see that you can divide the line into 6 segments, and so the double line is 1/6. Okay, wonderful. Now, I wonder if we can use your newfound knowledge of using pieces of paper to measure things to measure not just lines, but rectangles. Let's give it a try. Okay, so use the paper method that I just taught you to figure out the fraction of each rectangle that is colored in. Okay, I'm assuming that you have paused and now unpaused. Let's check your answers. The first one is the same way that we've been doing it this whole time. If you, I'm talking about the one on the left. If you measured along the line, you would see that you can break it up into 4 pieces, and one of them is colored in, and so it is 1/4. The next one is a little bit tricky. If you use the colored segment to measure the entire shape, you would notice it doesn't quite work. And so what I would suggest you do instead for that one is to use your piece of paper to measure the first white segment on the left and then break it up into those pieces. And if you did that, you would see Again, you can break it up into 4 pieces, and 2 of them are colored in. 4 pieces altogether, 2 colored in, 2/4 or 2/4. And the last one, again, I would not recommend using the colored in piece to measure it, because you can see on the left there is a smaller piece, and if you use the green part to try and measure the entire line, you would see that that smaller piece on the left wouldn't fit in. So instead, use the smaller piece on the left. If you did, you'd see that you can break up the entire rectangle into 5 pieces. 5 pieces altogether. 4 of them are colored in. And so, sorry, did I say 4 of them are colored in? I meant 2 of them are colored in. 5 pieces altogether, 2 of them are colored in, 2/5. All right, so that is how you can measure things to find out fractions of amounts of that shape without using a ruler. And remember, the most important thing is always making sure that you divide those shapes, or those lines, or whatever you're dividing, into equal pieces, because that way you can find a denominator that is the correct denominator. Because if you find unequal amounts of pieces or unequal parts when you are measuring your shape, then you will not be able to represent the fraction properly. So that's it from my computer. Let's go back to me. Oh, hi. So that's our fraction lesson for today. What I want you to do now is complete page 199 on the Jump Math booklet that I sent home to you last week. And that'll be your math homework for today. If you have a bit of extra time, my challenge for you is try and figure out how can you fold a piece of paper into 3 equal pieces into perfect thirds without using a ruler. How can you fold a piece of paper into thirds without using a ruler? Happy mathing!